Good day, everyone. Welcome to today's roundtable. My name is Celia, and I will be your host for today's discussion on how do digital lab assistants fit in the Lab of Future ecosystem. It is my pleasure to introduce you to our panel of experts. We have with us today Andrea Steinbacher from Roche, Andrew Garud from Novartis, Sridhar Iyengar from Elemental Machines, and Magdalena Palush from LabTwin. After the discussion, we will take some time to answer your questions, so please submit them in the questions box at the top left-hand corner of your screen. And if you require any assistance, use the yellow help widget at the bottom of your screen. This roundtable is hosted by LabTwin, who is developing the world's first voice and AI-powered digital lab assistant. And so let's first define what is a digital lab assistant. A digital assistant is a software agent which can carry out some tasks based on the user command. And in the lab, a digital lab assistant can assist scientists with hands-free data capture and access directly at the bench following their commands in order to support them in their daily task. But building the Lab of Future is more than gathering all the latest technologies in the lab. It means creating a complex ecosystem of connected scientists and devices, enabling seamless workflows and data flows. Several trends are shaping this ecosystem, and let's begin by addressing the vision of the connected lab. So a connected lab aims at building digital bridges between scientists, lab devices, and database or other lab informatics. And Andrew, you have a lot of experience studying the best solutions for scientists to interact with the lab systems. How do you see the role of digital lab assistants here?
Well, I think I sort of started by making a couple of observations. One is that over the last couple of years, we've seen that a lot of lab technicians that used to support the scientists in the labs have been cut back, and those, that assistance that scientists used to get all the time has gone away. So, you used to have people who would be there to help you find the reagents and to help you be able to, with experimental techniques, who to be able to help you remind you that you left the water bath on. All such things, and they've gone away. And I see that the benefit that you could get from a digital assistant is that some of that could be brought back, so you could have that sort of friendly voice on your shoulder, helping you understand, the environment of the laboratory you're working in, help bring you up to speed if you're a new scientist more quickly, and just generally sort of step into that sort of gap that has been created by perhaps excessive cost cutting. And then, I also see the voice assistant being another part of, the way in which we interface with our systems and our tools. The voice assistant is part of, it's a natural user interface. And I see that, for thousands of years, people used voice, gesture, touch, facial recognition to communicate and to collaborate and to get things done. And then we've had a bit of a glitch in the last 40 years where we've all been using keyboards and mice. And I see voice assistants as perhaps providing a way back into that so that we can get back to being a more human sort of centered world, and voice assistants will be part of that. And they go hand in hand with things like smart glasses as well, which will sort of help augment what you're looking at in the laboratory, as well as giving you audio stimulation and audio information about that. And then lastly, the assistant can probably help you tune into Spotify and play your favorite tracks. I know all scientists like playing the radio loudly as well.
Yeah, that sounds like an interesting idea to have the natural user interface of the lab. I like this this word. I think most of the scientists use a combination of ELN and LIMS in the lab. So Andreas, tell me, why would we consider having a digital lab assistant if we have already a ELN-LIMS system?
Yeah, well, I guess, Andrew gave the perfect explanation already. It's kind of the most natural, I would say, way of communicating, and that's why, voice or voice-powered assistants and digital lab assistants are really so powerful. But to be honest, I think we have to take here a bit of a broader perspective. Because basically, if you look into any kind of research, hundreds of years ago, well, at one point we went down there to go, documentation and writing somehow. And indeed, I can only echo what Andrew said. Well, we moved from, paper-based documentation to digital documentation. That's why we have ELNs. Yeah. And nowadays, of course, it becomes even more important because it's not just only for knowledge management and that what you've done 2 weeks ago, 1 week ago, or years ago, but also, to basically protect your IP. Yeah, meaning that is, of course, the role of an ELN. And of course, the LIMS system then is more, hey, giving things a bit more structure that I can, find, the data, and, then we clearly come to those fair principles. Nevertheless, well, the data needs to be captured. The data needs to be queried. The data needs to be massaged and, accessible. And I think there, voice-powered lab assistants can kind of really help, especially in cases where you're not, able to use a keyboard and a mouse. So I don't see, a big blocker on the one hand to have an ELN or LIMS and, a digital voice assistant. Yeah. So that can always go hand in hand.
So Magdalena, do you agree? Is it the role which is envisioned by the clients when they implement LabTwin? Magdalena, I think you're muted still.
Yeah, sorry. I'm really bad with that.
No worries.
Thank you, Celia. Yes, I absolutely agree with Andrew and Andreas. I would also add that these days context is everything. So the role of the assistant is to become an expert in this context. And that means first shadow, connect, learn, capture, and then be able to communicate and deliver that insights based on that context in real time to the users. I think many organizations we work with have already data lakes, ingestion initiatives in place. But still, like adding context and metadata to that data and that data lake is still often either missing or is a challenge. And the missing context today still most often either comes from the user, from the technician or the scientist that works in between these different islands of data, from equipment that he or she might be using while handling different experiments, or from the environment itself, being the laboratory, either the temperature, humidity, things like this. So I do see the role of the assistant to be able to absorb that contextual data and enrich the information and then feed it back to the user, to the technician, scientist, or automation engineer working in that lab.
Yeah, so interesting, and it's good that you mentioned things like temperature and humidity, because we have Sridhar with us also, who is helping the digital transformation of lab with IoT sensors, collecting continuously the data from lab equipment or the environment. And so, Sridhar, how would you see the interactions with the digital lab assistant, or do you have any example in mind that you could share?
Yeah, absolutely. So first of all, thank you for having me. It's a pleasure to be here and talk about this whole new digital transformation in the lab space. The one guiding principle is for a digital lab assistant to be effective, they actually need data to act upon. And that's the role that we see elemental machines playing in getting that data into a queryable and actionable form. And what's unique about the laboratory space is it's a very physical environment. There are machines, instruments, there's the ambient environment that will affect the results, there's the samples, the reagents, the chemicals, the whatever, how they're stored. And so one of the main things that's important for an assistant, a digital lab assistant to be effective, is understanding the interconnectedness between all of these things. So as an example, knowing when the last time this instrument was calibrated. Imagine having your lab assistant or digital lab assistant tell you, wait a minute, don't use this machine, it's past due calibration. Or when you bring a sample to use or a reagent, to say, wait a minute, that wasn't actually stored properly because that fridge went offline last night. Or in the case of people who work with polymers, the humidity today is a little bit higher than it should be, so just be mindful before you run your experiment. So for a digital lab assistant to be effective, all that information, contextual information, I think somebody mentioned metadata, that has to be brought into a form that can be queried and consolidated to give the appropriate recommendation or insights to the person who's about to do their work at the station.
Thanks. So yeah, as it seems, it's anyway helping a lot in this connections between the different devices and the humans, the scientists in the lab. And so that's why I want now to move to the next aspect of the lab of future, which is the human-machine interaction. And automation is a growing trend, which is slowly filling up the lab with more and more robotics and automated lab equipment. Robots would take over some manual tasks from scientists, but others rather believe that scientists can be augmented by digital tools to accelerate their workflows. And workflows and processes are becoming more and more automated to the point that now some labs invest in robotics to handle this task. And Andreas, you're expert in lab automation. So what is your view on the current status of lab automation, and how would you envision the coexistence of automation and digital lab assistants?
Yeah, thanks for that question, because I think, it's not, a coexistence, but it's, a necessity that you have actually both. The point is, if you have more and more automation going, and nowadays, what I see in the industry, you have actually things that I call automation islands. What do I mean by that? That might be a liquid handling platform with some connected analytical devices. It might even be, several of those automated devices with, a conveyor belt or, a arm connected somehow. But, we're still a bit far away from, that manufacturing process in R&D, that you have, one big plant or one big, let's say, machinery that, where your sample runs through end to end. And the point is, will that ever happen in R&D? Will there always be the need for, full automation in R&D? Or is actually R&D not about to have, distinct, activities that will, never be automated right from the start, but you will just start kind of small. And that's why I think if you look, especially in big pharma or, in the life science space, you will always have things more like, a connected lab, with some digital flavor and digital assistance, or automation. And you then gradually grow those automation platforms. And I think then, there's the decisive point that you want to connect those different automation islands and platforms. And for that, it's for sure, you need kind of a digital lab assistant. The point now is you come now with, a term that I use often, like a digital workflow, because, your scientific discovery workflow needs any kind of digital representation. The point is, the bigger your automation is, and, probably you want to go, and drill down, and, then the closer, you want to go to a detail of your automation island, the closer you come to manufacturing. Yeah, and then, your digital lab assistant can actually be powered again by a keyboard and a mouse. However, the smaller actually your island is, and the more you have still some manual activities in there, then the point is you want to have a companion with you, and then voice, but also augmented reality or VR, is really kind of important, because in R&D, what you will see is always that the need for flexibility in automation. So what you need your digital lab assistant for is connecting those islands, and be able to reconnect them by basically designing a new digital workflow, just because you designed a new scientific workflow. And that's why I clearly see for digital assistants, two big directions that hopefully at one point really bridge. And that's one more where we're coming from in our discussion, the connected lab, really where you have a lot of manual tasks, and on the other hand, really close to manufacturing already, yeah. And of course, now there's everything in between, yeah. But these are the two big branches. Their digital lab assistants, really will play a role, and especially the more you move to more, the manufacturing shop floor type of work, you will need a digital lab assistant to kind of power that work.
Okay, so it would be a bit two different style of role depending on if you're in the R&D labs with this automation island, and if you're in the manufacturing side where it's mainly the scientists that are outside the lab and just come in if there is some issues to be solved, I guess.
Yeah, you could think of, if you have like super manual tasks, the point is not, automation won't help you there. You might be at the fume hood, you might be at the bench doing something, but still there's a need of digital documentation, where a lab assistant can help you. Or, things that Sidar kind of mentioned, to say like, hey, warning, humidity is high, or hey, warning, your stock is out of control, whatever, that can help you. In a fully automated system, that probably does not matter anymore because, well, you have automatic processes to kind of pile up your stock management somehow. That's kind of fine. Still, an assistant might be necessary to keep all that, into place and in control, to kind of power the automation. And you probably will ask different questions, more like monitoring, getting a status for what's going on, and not, that much, driving and, active interaction.
Mm-hmm. So I think, Andrew, at Novartis, you've been using a companion for the scientists regarding automation in the lab. Is that right?
There's been some work done to looking into using voice assistants and companions in the labs as well. But I think one area that you have when you have a lot of automation and the type of laboratory environments that Andreas was describing there is you also need some sort of help for the people who are in those spaces. And that help is not always available directly in person, especially at the moment with the whole pandemic situation. And so, one of the areas that we've been exploring and has been looked at is the use of augmented reality headsets. So the HoloLens, for example, is something that was experimented with to assist a scientist in a laboratory environment. And as part of that, you need to have audio input as well. You have a voice assistant in the headset, so you hear voices in your head, which is slightly strange. But you have a headset that can help, provide information and guide people. And in the context of the automation, and learning these new systems, people need to have sometimes an engineer or a specialist flown into them, and that's not always been possible. So what you're seeing in both, the pharma industry, but also other industries like the US military or the aerospace industry, are people being guided through complex procedures to repair equipment or to make it work or to go through processes and procedures that require normally a more skilled technician, but with the aid of an augmented reality headset guiding them visually about where to plug things in and pull them out, they're able to be assisted in that by a remote engineer who is somewhere else. And I think this is the sort of assistance that we're talking about. We've talked about, the voice assistant plays a part in that, in helping guide that information. And so it can either be done by a human or by an automated system that sort of walks you around the steps. So, for example, you can replace an HPLC column without having prior experience, because overlaid onto your vision is, a diagram of the equipment and which bit to plug in where. It's like the ultimate Lego guide for using. So, we're seeing smart glasses getting some interest there. And I think in the future, we'll see them really taking off.
Good. So, Sridhar, I believe that the data you extract from lab equipment or the environmental sensors can be both used by humans and machines, right? So do you think the human component is still essential in the labs? And how would you see also the digital assistant or the companion's role here?
Yeah, that's a good question. It's one that I get asked a lot. And I point people to the example in the medical space. There's been a lot of AI and machine learning technologies being applied to medical imaging, and radiology in particular. And maybe 5, 7, 10 years ago, there was quite a bit of speculation that AI is going to put radiologists out of work. And in fact, we've seen just the opposite. That what's happened is AI tools have made radiologists a lot more effective and increased the throughput, so the cost of delivering their service has actually gone down. And so the role of the human being is always going to be there, because any system, any automated system, a computational system can only be trained, can only perform based on how it's been trained. Now, work around automated discovery and automated science has been going on for a while, and I believe about 10 years ago there were two robotic systems powered by an AI engine. One I think was in University of Cambridge in the UK, and one I think was in Manchester in the UK. And funnily enough, they were called Adam and Eve. And they were automated systems that were trained to carry out certain types of experiments, and they actually succeeded in discovering new materials and coming up with new synthesis techniques based on their training. It's taken about a decade, but we're seeing some of those concepts being put into practice. There's a company here in Boston called Cubotics that many of you might be aware of that's actually doing something along those lines. And so what we're seeing is the automation and AI parts are being used as tools to really augment the way human beings can actually innovate. And so to outsource the repetitive nature, or maybe to train a system to innovate in a very defined space. But basically, I don't think it's really going to put scientists out of a job. In fact, it's going to be the other way around. It can make them increase their throughput. And I think that's what we're seeing now in the industry.
So we need both. We need the robots, but we definitely need humans with superpowers.
Yeah, I think all of our jobs are safe.
Yeah, that's the main, I think, questions. Even though I guess some jobs might shift a bit, right? It's maybe not anymore manual technicians, but rather technicians towards robot systems, or the knowledge as data scientists or as engineers would be also more present in the lab to interact with the systems.
Yeah, basically, yeah, you're absolutely right. Basically, what ends up happening is that the human being moves up the value chain, and automation takes over the more repetitive tasks.
Yeah, I think there you're really spot on, because, it's about the repetitive tasks. But, be aware, if you're now in biotechnology, or even, in the chemical space, or, in general in the life science space, if you run an assay manually, you do it with your hands. Of course, you get kind of better and trained because, you're better in those repetitive tasks and make less errors, I would say. However, it's still a skill to kind of put that onto an automated platform, because it's kind of different if, a robot is pipetting or if you as a human is pipetting, yeah? So there are certain steps you would never ever think in your, manual workflow that you need to take into account. And that might be simple things like stirring, heating it up a bit more, and, waiting times and all of that. So that is also a kind of a skill. And for that, it's not like that you can easily just, train an AI for that, because, well, you have to discover a certain, space around it. Yeah. So I think that until that, really can take up, being taken up by a machine learning model or AI, that will take some time. And still, again, then, you need humans to kind of, build those models and train those models. Yeah. So I think, those skills might shift from actually, being perfect in doing it 300 times a day into, okay, I take 3 weeks now to get it perfectly set up on an automated platform that then runs, for months or weeks.
Yeah, that's an interesting thing. We forget about the fact that we don't just buy a robot and put it in the lab and it's already working and doing what we want it to do. So Magdalena, you have users, right, that are working with robots. Can you tell us a bit more about how they've been finding Laptron useful, and if you agree with the previous mentioned roles of a digital lab assistant?
Yeah, absolutely. I agree, and this has always been a very intriguing discussion when we get to a full automation. To me, this is very analogous to other industries like Andrew and Dad already mentioned, where we saw automation maybe already progress much further. And what comes to mind is actually automotive industry, because when you take, for example, autonomous drive, there's like 5 stages of this automation that are planned, right? And we're in like the second, maybe some would argue in a 3rd stage. And it started with the assistance type of enhancement, and then it moved to a partial automation of certain features that's still more of the human is still in control. And what we often forget, or we don't think about often enough, is that in order to move through the stages, the first stages really need to be taught by a human being. So before the vehicle can learn how to drive autonomously and make the right decision, which is most critical on that way, certain amount of learnings and miles has to be driven by a human driver to even create an infrastructure and sort of information model that then the the machine can kind of execute certain tasks. And I think that's similar in other areas such as laboratories. So I completely agree. And at some of our customers, assistant can already prove helpful in this process of and some of the customers see the role of the assistants as enabler of automation because of that story I just described. So in some area, we already see, for example, automation engineers who need to actually program different robots to take over these islands that Andreas was describing, some of those tasks that are manual. For example, transferring samples from one well plate to another and sort of transferring that protocol from a human sort of protocol being executed by humans to ones being executed by a robot. And in that process of actually programming and experimenting and fine-tuning the setting, the automation engineer actually needs to document it, first of all. And while he's documenting, he needs to actually keep an eye on the robot, of how the robot is actually executing on it. And once that is actually fine-tuned and all observations are noted, all the settings are noted and recorded, then that automation engineer now needs to teach the rest of the team or the rest of the lab of how to actually use that robot and that protocol now being fully automated. So in addition to some of the comments made by my colleagues, I would say also sort of enabler of that automation islands is also another way we see our customers leverage assistants today.
So I think that's a big picture of already how automation and augmentation can work hand in hand, hopefully in the next years in the R&D lab. Another trend that has been in the spotlight this last month is the need for remote work and remote access to data in real time. And it's a need that was already there and was only accelerated by the pandemic. I remember in my lab, we were monitoring our semi-automated experiment from our phone during lunch or at home through TeamViewer, tweaking the parameters or just pressing stop if there was a problem occurring. So do we have already the technology to empower remote work, or what are the remaining challenges, opportunity also for digital lab assistant? Andrew, do you want to start?
Yeah, sure. So I think you quite rightly pointed out that we do already have some of these tools in place to do remote monitoring of experiments and what's going on in the laboratories. And I can remember people doing it with webcams all 14, 15 years ago, back when the internet was like something you dialed up into. It was nice and slow, and Yahoo was a thing. But what's not really there at the moment is it's not really seamless. We're at the Nokia smartphone stage as opposed to at the Apple iPhone stage with this sort of technology. And, we've got stuff, technologies from companies like Elemental and, the IoT sort of space that's really helping enable the labs to collect more data and to collect more information and enable you to understand better what is going on with your experiment in real time. And at the same time, we've got this situation now, but it's also been going on for a while. Scientists don't want to spend all day in the lab if they don't need to, just sort of stood there staring at a water bath and the thermometer. It's very old school. Most scientists I know would prefer to be in the bar and clicking on their smartphone to watch what's going on. So the tools and the technology are there, but it's not really been put together in a slick package yet. And I think what we lack is that sort of sophistication. And I think within the pandemic, everyone's now really got into having like these Ring and these Nest door phones that tell you when Amazon are coming to drop your packages off and all that sort of, so we remotely monitor our front doors, we remotely monitor our houses, and we remotely monitor the garden and watch the birds. But we're way away from that at the moment with the laboratories. And I think there's a huge amount of opportunity there to improve that and to make that into more streamlined packages. And I think, at the moment, what would happen is you might have something that would send you an email or an SMS or an alert. What's lacking is we're lacking something that brings it together. So, if we can sort of like have that brought together by an assistant that sort of like, and preferably an intelligent assistant that can sort of say, okay, right, well, the water bath, the temperature parameter's okay. I won't phone Andrew just now or notify him that there's a problem. Or no, there's a serious problem and this does warrant intervention. Here's the link to the webcam to show you exactly what's going on. Would you like to make a change? I think that's where an assistant could sort of like help you out. It's like having someone in the lab 24 hours a day, but without you having to be there to monitor it. And hopefully it will give a better work-life balance to the scientists, as well as the current situation where they have to work remotely because of the pandemic. So yeah, I see there's a lot of opportunities there. And if you can have a digital assistant that can gently remind you to do things and gently help you to get through these problems, rather than just sort of some clunky automated system that sends you some cryptic error message written in IT language, I think that would be beneficial for the scientists.
Yeah, that sounds good. The humanization a bit of this error and notifications that you can still access today. And also, as you said, like proactively also monitoring by already helping with the decision, already pre-processing maybe the errors and only pointing out what the human need to decide on its own.
Well, another good example is if you look at the aerospace industry, we're already in a situation where the airline engines are being monitored remotely via location. I think it's based in the UK for the Rolls-Royce engines, for example, and they'll proactively know whether there's a fault developing with that piece of equipment, and they'll have something on courier to the airport to replace the fan blade before you even notice that you might even have a slight glitch. And it's that sort of proactive monitoring. I think that'd be good. I mean, I think we've all experienced or seen scientists suffering from the fact that a piece of equipment goes down, a very expensive piece of equipment goes down, and then it's weeks or months before they can get spare parts. If you've got a digital assistant monitoring, proactively the condition of your equipment and preemptively ordering replacement parts to come through to you before you even know you've got a problem, I mean, that's fantastic. That's like having a real live technician in the lab who's super on the ball and super sharp and doesn't quite drink so much tea.
Yeah, it's a dream of everyone having such a technician in the lab. The mom of the lab, we used to call her. So a lot of pharma allow now the usage of their own devices for the scientists to already have a bit this feeling of using their mobile phone to monitor things in the lab. And also now from home, their own computer to access the different databases or ELN. And this brings a lot of new questions about IT security, of course. So, Andreas, what are your thoughts on the current concern for IT security with remote work? Do we have good solutions? And also, how can we manage to make it all smooth and secure and still allowing data flows between the home or the mobile and the lab?
Yeah, I think that's a huge topic right now. And, I really feel you, Andrew, and, what you shared right now, because I think, indeed, back in my PhD days, even if you were sitting in, your office at university and, 2 doors down, was your lab, you still had TeamViewer open or webcam open to kind of monitor what's going on in the lab. And, if something goes wrong that you could just run over, but still you could do, other stuff. Yeah. And especially for works, there are these weird, times where it's just not useful just to stand there, because every 5 minutes you want to, change a parameter, so you try to automate it a bit, and I think, that is reality in life science labs, all the time. Yeah, and indeed, I absolutely feel you. It's like super clunky. It's not nice. And typically the first step is always monitoring, and then the second step is always asking, okay, but how can I now interfere with it? Yeah, and because then at one point you move from sensors to actuators, and then things go into the automation part, and then things go interestingly. Plus, of course, IT security comes now here into play, because it's not in the well secured on-prem, let's say, network, but you really have either to tunnel through VPNs or other technologies, and that brings you, of course, also, it's a certain resource bottlenecks. Well, you can circumvent that a bit if you go to, virtual private clouds, because then, you might be easier from a computational perspective, but that doesn't solve the whole problem at all, because then the point is, okay, do you really want to put, all the data to, a non-company provided computer, data breach and security, and certain pharma companies are really, really particular about it, meaning going that far that there's no USB port available at a laptop that you get, and all of that. Still, I see clearly there's a big ask for that. And I think, the industry is moving in that direction just because of customer needs, and, clearly seeing the benefit that if you're sitting at home, you can still do meaningful kind of work. And for me, there's one big question, and I think, we touched a bit on that, is, predictive maintenance, and also, that augmented reality, meaning, you get trained by, whatever, an instrument provider, well, not even trained, but you're guided, you have your smart glasses on and someone, in your ear telling you, okay, now lose that screw, take that out, put that in, and that's all fine. What I clearly see here on the market is, of course, again, every single vendor has their own approach and their own system. Yeah, and if in a bigger life science community, well, in your lab you don't have everything from one vendor. Meaning you have 8 headsets lying then around, and that comes again to IT security topics, because do you really give all of those vendors really access to your network kind of? And I think there we really lack smart solutions. Or that also the pharma industry, let's say, adopts certain security standards. And just because I think that's especially in that R&D environment where we still try to be super flexible, and it's not easy to get all these IT security clearances and all of that. And therefore, I think, that could be a part where also kind of digital assistants, could play a role, because basically they could bridge that gap somehow, so that you kind of go with only one assistant, and, that is clear with security, and all of that. And then, hook into various, either instruments or, look for, various monitoring systems. Yeah. So something like that, would be really, a huge leap forward.
Yeah, that's interesting to see that there is several solutions that can be taken to go over this IT security concerns, and that's a big fight between on-premise and cloud computing right now. Sridhar, you've been also facing this need for remote connections or sharing the lab data from home. How did that go?
Yeah, it's we obviously saw a market increase in the need and demand for all this last year, thanks to the pandemic. But we also run into some interesting challenges, and I think Andreas touched upon a few of those, especially the IT security piece, because all of a sudden, IT departments are challenged with a whole new use case of access into the network. Through devices, through third parties like us, and even a much larger number of employees within their own organization. So that's obviously one of the things that the industry is struggling with. But also there's, and I think as Andreas also mentioned, the fact that you have 15, 20, 100 different vendors, all of whose instruments and equipment need to be consolidated in a unified way. And so what we're seeing as the challenges for true adoption of remote monitoring is being able to solve that multi-vendor integration problem, but also do it in a way that allows different stakeholders in the organization, in the customer's organization, to actually make use of the data. So, for example, you have the actual R&D scientists who need to look at data in a particular way. On the flip side, you have the lab managers or maybe facilities managers who don't need access to certain individual data sets, the analytical data. They need something that's more what we call summary statistics. They need utilization data, aggregated data. And so being able to construct those consolidated data sets and consolidated insights as opposed to the raw data is something that you're really looking at two different use cases. There's actually a third use case that has come about, especially in the synthetic biology world, in that you don't necessarily just have the scientists who want the analytical data. You have data scientists who want real-time API access to everything. That sort of flows into their own custom data analytics platform, whether it's Splunk or whatnot. And so for folks like us that are trying to build that connectivity layer, what we're seeing is there's the analytical raw data, there's real-time API access we need to solve, and there's IT security issues we need to address, and then there's consolidated utilization and statistical summarized aggregate data that we also need to present to different stakeholders. And so that's kind of the overarching use cases that we've seen dramatically more visibly visible this past year. But ultimately, if you ask what's the biggest barrier to adopting these kinds of new digital technologies, we're not really competing with other digital technologies. We're actually competing with paper and pen. And I think the biggest barrier to adoption is just the familiarity and convenience of writing something down, sketching something down in your lab book or on paper. And that, I think, is generational and cultural. So as more and more people become digital natives who get into roles where they can embrace these technologies, we'll see that kind of legacy behavior probably fade out over the next 10 years or so. But it's never going to fully disappear because there is something magically convenient about paper and pen.
That's true that the main concurrent here in the lab, but also at home, but there's a lot of different other tools that we could use at home. Magdalena, did you see some use directly of LabTwin from home or at least outside the lab already?
Yes, we did. But I guess just to adjust what Sridhar was saying, absolutely, I agree. Until the moment you are searching or you're trying to troubleshoot and you're searching for that one piece of paper you noted something on. And I think this is where we haven't seen yet, just because we haven't crossed the threshold of actually having this much data easily searchable, that the carrot is very visible, that the fact that if I have a choice, note something on a paper, or I know what noting something digitally would mean for me later, we haven't experienced that rewards enough yet. Until when we do, I think that shift from paper and pen to digital will be much more powerful. We have seen already users in a lab being able to take notes on the go when they're commuting in traffic and they are already thinking before getting to the lab what they're going to be started to do. They would actually like to be able to just control and start certain equipment that takes a while to get started once they get in the lab. So planning on the work they're going to be doing that day before they get the lab, real-time data exchange, especially during COVID when not everyone can be present in a lab, so leveraging for that, notifications, receiving notifications on their mobile and status of different experiments and work being done in a lab. We've seen a lot of that. And I think to add on the trends that we're seeing, and I think you all have read that Gartner published 7 trends in data analytics in 2020, and one of the second one was decline of the dashboard and emergence of what they called more of a dynamic data stories. And what that meant is basically a shift from predefined dashboards as we know them today to more of an in-context, again, data that is relevant to, it's streamed directly to a specific user, knowing day, context, time, location, workflow that is being executed and raw. So I think, again, analogous to different industries where the personalization of that data, such as medicine, personal medicine, being able to know, and assistants can do that because they personal to the user, they understand the context of the user in the moment. So being able to enhance this aggregation of information that Sridhar was explaining, making it actionable to its very specific context, I think is the advantage that we can offer. And we're beginning to see some of this already.
Adding to the comments there about paper, I think it's a very good point that was made that, until you beat paper, you're still going to be behind. I'll be interested to see how things develop now, because a lot of organizations are moving to flexible desk spaces. So the typical way in which you kept track of things is you'd have a forest of Post-it notes around your desk and on your lab book. And, if you're not able to use the same desk every day, that methodology breaks down quite rapidly. I don't know if anyone else has ever tried to keep a stack of Post-it notes and resort them out every time you go to a new desk. It doesn't really work very well. And the second thing as well is that, you can't take those Post-it notes home very easily either. And I think that's where the advantage of having notes on the go will help people out, because you'll have your Post-it notes with you at all times. It's a running joke in my organization that I'm a big fan of the sticky notes on Windows 10, because sticky notes on Windows 10 you can put around your virtual desktop, and it now synchronizes with OneNote and all the other tasks. So you can have your sticky notes follow you everywhere you go, and you can sort of edit them while you're on the bus, if you still use those. So I think that's a good thing that, paper has been the challenge. And I think it'll be interesting to see how the new ways of working make paper less useful finally, because you can't keep it with you as readily as you used to.
Very good point, Andrew. And I think additionally also we're witnessing, especially in this new normal, more distributed way of working. So we have some groups, and the handover of works becomes much more frequent. And that also, to add to your point, now if someone else comes in to pick up that Post-it and then make sense of the last step that was done, it's not so easy. So this is, I think, also where more of a digital way of documenting sort of wins.
Nice. So I think we are reaching slowly the end of the discussions, and we will open the Q&A session in a couple of minutes. So please send your question in the question box. Now is the time. And as a conclusion, I would like to ask each panelist to answer the title question. So how would you frame the place of the voice assistant in the lab future ecosystem with one word or a very short answer? Andrew, maybe you start.
Yeah, sure. So, I mean, I see voice assistants as being, part of the toolkit that goes into the lab of the future, in the same way that, voice assistants have become part of the home of the future already.
A toolkit. Nice. Andreas?
Yeah, it's a tough one, and I hope I don't steal, your words, Magdalena. But I think, really that resonates with me a lot, and that's enabler, or enabling. Yeah, so I clearly see that, digital assistants in general, but especially also, that voice-powered, assistants, they can enable, or unleash, certain applications.
Yeah, that would have been my word. That would have been my word, but I would say maybe I add another one, which is a gateway, the gateway to the information in real time.
Yeah, I'm sorry about it, Magdalena, but it's really, I think, well, really that's live, that kind of really is catching it, yeah.
I'm glad we aligned.
Sridhar, what would be your word or short answer here?
Yeah, so digital lab assistants, even in the lab or in outside the lab, they have to feel natural and be seamless in how they perform. And I use the example of Siri. Siri is pretty good, but it's not as good as I'd like it to be. But it's good enough for me to use to leave memos and text messages and emails when I'm driving, because the alternative is to do nothing. Whereas I don't use Siri when I'm at my desk because typing is actually much more accurate, even though it's more laborious. So depending on the context, the way that these lab assistants, voice assistants perform has to be seamless to that context. So in the car, I can deal with some issues, but when I don't have to deal with those issues when I'm at my desk, then I demand much higher perfection. So the context, the seamlessness, and the naturality of interaction has to fit the context in which it's used.
Maybe I add to what you just said as well. I think we're talking about an assistant in a sort of a broader context of what we experience as Siri or Alexa or Google Home. And I think what we need in environments like laboratories, more experts and specialist assistant. And I think for that, we actually do need to train them and develop them. Just like I would, if any of us have, have worked with an assistant before, executive assistant, that you know that you actually have to share quite a bit of knowledge in order to be able to work with that person really well. And I think this is similar with these systems. You actually they need to become an expert in your context, and that's sort of the first step to get there.
Good, so I will start now with the questions from the audience. So the first questions, I think the million-dollar questions. How can we measure our ROI on new technologies such as digital lab assistant? How do we justify the investment? Does somebody want to start on that?
Yeah, perhaps I can take a shot, and that comes more from the automation space where I actually said, it's a necessity. This is clearly what we see right now, that if you have those, automation islands and you want to connect them, you have to have something like a digital assistant, If it's now really powered by voice or, still with, a keyboard and a mouse, then that's a different story here. But, if we are speaking about the general context of a digital assistant that guides you through your kind of digital scientific process, then it's really a necessity. Yeah, and then it's rather straightforward to put also an ROI on it. And let me briefly elaborate on that. You can think of, okay, I now buy something like a liquid handler. Why do you do that? Well, of course, what you want to gain is kind of a certain throughput, meaning instead of having, someone like a human standing at the bench and pipetting, well, that can be done by the machine. Well, what that does now is, you have to give that machine input, like work lists, meaning what sample should go from which, source well to which destination well. Yeah. And sometimes, that must be generated somehow. Yeah. And of course, now you can just, have a human sit down there in front of Excel and, typing it, all of that, not down, which is super tedious. Yeah. And no one wants to do it, meaning you need smarter ways to do it. Yeah, and that clearly gives you already an ROI because the point is, either you buy a machine and you shift the human capacity from doing the pipetting step to tedious computer work. Yeah, so really to gain something, you need to take that away. Yeah, and then you clearly have that ROI.
Thank you, Andreas. Andrew, anything to add on this?
No, I mean, ROI is always a tricky one to deal with. But I think there's a lot of ways in which you can now measure productivity. I don't know if anyone else has seen this, but you've got the Microsoft Workplace analytics tools that can be used to measure productivity. So in terms of measuring ROI before and after you implement an assistant, it's probably possible for that to be measured these days.
Thanks. Very practical advice. So I have my second question, which is, starting with a comment and then towards a question, so bear with me. Adding context sounds good. In practice, this means adding some metadata, but we have had big issues with standardizing metadata use across researchers, not to mention research teams. The problem is we don't really know what type of metadata will be useful and what is just clutter. Could you comment on what type of metadata could be useful with a digital lab assistant?
I can jump in on this. This is something that we've given a lot of thought about. And I completely agree with the fact that just adding a bunch of data isn't very useful. But there are some standard ways of doing this. And there's organizations like Allotrope who are coming up with certain formats that we can structure it for future data mining. But I think the thing is, there are two ways of looking at this metadata. One is there something that you can use out of that metadata at a point in time when you need to make a decision? So a go, no-go decision. So a simple example I think I gave in the past or earlier was was this reagent stored properly, or is this machine calibrated? Or as I'm sure everyone knows, as someone in the lab where you want to know who used this machine before you, because you kind of know that if somebody, if Dave used this machine before me, then I'm going to have to. There's a good chance he broke it, or he left it dirty. And there's always, as Humor said, there's always situations like that where knowing an actionable piece of data can help you make a decision one way or another. So that's one. The other is a way of determining unknown unknowns. So oftentimes you don't know why a result turned out a certain way, and the usual way of addressing that is to look at it from a theoretical standpoint and redo the experiment in more controlled conditions and whatnot. An alternative way to do that is to capture as much data as possible throughout the entire experimentation, from sample prep to what instrument you used and time of day and whatnot, and then do a mass multivariate correlation to see what might pop up. And we've actually had experiences where some folks, some of our customers have actually done that and are able to pinpoint, oh, it's probably due to this environmental condition. And that's a situation where you don't know what you're looking for. So gather as much as you can in a structured way, if you can do it automatically without any effort, and then do mass cross-correlation. So those are the two main use cases that we've seen for collecting metadata.
Yeah, I think it's a common trend also with science. Now that we are going to big data, we don't really just start with an hypothesis. We just look at all the data and try to run cross correlations and see what is coming out. Magdalena, you wanted to add something?
I think it also is very, it could be very workflow and obviously experiment specific. So you'd be looking at maybe more time sensitive materials versus temperature sensitive materials. So to some of it, I think it could be standardized. You know that maybe hypothetically certain metadata would be more relevant to certain workflows than in others.
Yeah, and in general, so I think, you were spot on here. You can either go big, and say like, try to get whatever you can, also from a metadata perspective. But what I see, in recent years is actually that typically we don't even catch, really the scientific core data very well. A simple example, and I know you're working on it. If you just have, a certain synthesis protocol and say like, okay, now please stir, for 20 minutes at a temperature of, let's say, whatever, 85 degrees. Yeah, and if now two people do that it will turn out to a completely different temperature profile. Yeah, because the first one will kind of heat up, okay, reach the temperature point. Now I start the timer. The next one will just say, okay, heating up, here's my PID curve. Do it, I start the timer. Meaning that's already completely different, but that's really, scientific content. Yeah, so that was the first point I want to make. And the second one, if it comes really to metadata, because you can really gather a lot of metadata. Yeah, where to stop there somehow. Typically, I use always the guiding principle. Think of, the needle in the haystack. Yeah, what type of metadata do you actually need to recover exactly a specific data set? And that gives me typically always, a very good guiding factor to say like, okay, do I need the operator? Do I need the lab? Do I need the day, time step and all of that? And then you come to, at least a minimal data model. You can always do more. Yeah, and that's kind of fine. But that's a minimal part. And at one point, especially if it comes to research teams and getting more metadata, the point is typically it then is very unstructured and kind of free text, and no one will read it again. And if scientists realize that, okay, I'm forced to capture something here, but no one does read it. Why should I do something then? And then it goes in the other direction, and you're like, okay, let's make everything type safe. Only drop down list, and you have mandatory fields, and you have to select something. And then typically your data quality goes down. Yeah. So please don't forget by all the data capturing. Don't forget the usability and the user. Yeah. Still, someone has to do that. All. And if it's not automatically captured, you really have a hard time.
Something I see promising with regards to, so like I agree with Andreas' point there about making the data capture very easily and streamlined The thing that always springs to my mind is smartwatches and Fitbits and like the Apple Watches. They're collecting a tremendous amount of data about what's going on around you and the environment. And we're also seeing the same thing coming to headsets. They're bringing in chipsets that will capture what's going on in the background of your, who's having a conversation, sentiment analysis of how angry you are on the phone, etc. So there's lots of stuff being captured by, sensors that are on the scientist and in their environment. And that's, for me, is an example of how you can capture that information without it being too obtrusive. No one really thinks of going out for some physical exercise wearing a smartwatch, and it's not like you have to run it down and note every 5 minutes how fast you went, or click a little button to capture, your split times. It's all being done for you by a small piece of technology in your arm, and I think that's the key, is to make sure it's as unobtrusively collected as possible.
I think that was a very good conclusion for this interesting discussion that I would have liked to go on a lot with, but unfortunately our time is up. And so I would like to take the last minute to thank our panelists for sharing this fantastic insights, and thank you for attending the discussion. And I will let it over to Stefan to conclude.
Thank you very much, and thank you to all the speakers for the great discussion. Also thanks to Uptwin for sponsoring this session. If you'd like to watch the on-demand version, you receive instructions on how to access that sometime tomorrow. And additionally, you can watch the on-demand version on our website, which is www.businessreview.com. Thank you once again. I hope you have a great day.